Let me see if we can dig in a little deeper in that here about the limits of deduction and induction, the limit of mathematics and
Sure.
science in general. A certain kind of criticism stems from the argument that you see, if we are perfectly logical, then we would be nothing more but mere machines. I mean, philosophers and poets for thousands of years have extolled our emotional intelligence.
Hmm.
So, do you think that? Okay, so let me ask you two questions here. First of all, is there any way that a computer system or machine learning algorithm can take into account such emotional intelligence? And two is, do you not think that if that's not possible, there is something lost in the world, in our ability to perceive and model it and react in it and predict and model the future?
I view our emotional systems in our brain as being, well, first of all, extremely useful. I mean, anxiety helps alert us to danger. Anger helps us prepare us to fight when we need to fight. I mean, our emotional systems are obviously incredibly useful to us, and we could not get by just with our analytic thinking. And I'm sure that there are cases of brain damage where people lose a lot of the emotional systems, and I would strongly suspect that they're highly dysfunctional people. So, I mean, but I think when we talk about logic as being like sort of the end all of things, I mean, it's a bit making a bit of a mistake, because ultimately you could create a machine that was, suppose perfectly logical, but unless you gave it preferences or values or desires, it wouldn't do anything. Logic is something that you can use to accomplish a goal, but you need to know what goal you're trying to accomplish. And logic can't tell you what goal to accomplish. That depends on what you value or what your preferences are. And so I view them almost as separate things. You've got logic as an incredibly useful set of tools, and then you've got preferences.
And in that sense, then, it seems that we have to have a way to input the values, or if you will, the ethics behind or underpinning that kind of a logical system, right?
Mm-hmm.
So, is there a way that we can do that in machine learning or in artificial intelligence at all?
Well, in machine learning, you do specify a goal of the system, and the way that you generally do that is you give it an error function, a function that measures sort of how bad the mistakes it's made were, and that actually implies basically what it cares about maximizing, or what it cares about optimizing. But machine learning today is used for very like specific tasks: face recognition, language translation, investing, things like that. So your error function would be related to the task at hand. If it's identifying faces, you might count it as an error whenever it misidentifies a face, for example. So when you're talking about more general intelligences that go beyond the narrow AI of today, it's a much more complex task. It's very hard to define a set of preferences or values that say matter to a human being or matter to all human beings.
Absolutely. So, before we move on to the sort of technological singularity related questions of our interview, do you have a tip or a single advice for some of our viewers in terms of the best way to approach investing in a world of exponential technology?
Well, one thing to note, and I think this is sometimes sort of overlooked, is that exponentially growing technology, for example, in the number of transistors on a chip, is not the same as exponentially growing value. Going from 1 gigahertz to 2 gigahertz does not allow you to do that much more, relatively speaking. I mean, it's not the amount of value is not doubled to having that chip. You can still do most of the things that you want to do. Whereas if you had a much slower chip and you doubled the speed of that might actually be really valuable. It might let you do things you couldn't have done before. So I mean, I think I would differentiate between when you see certain technologies growing, you need to ask, well, how much extra value are we actually getting out of that? And that's an important question to ask. But I would also add that you don't, in terms of investing, you don't need to be leveraging technology to do a good job at investing. There's still people like Warren Buffett and other value investors who are able to basically use their knowledge of what value is and how to measure value, and use essentially the fact that sometimes the markets behave irrationally to make good investments and to profit. And they're not technologically sophisticated at all. But on the other side, um, the fact is that there are ways in which the world is changing dramatically. And so, for example, computers continue to get faster, algorithms continue to improve, machine learning algorithms continue to improve. And so we should expect that more and more tasks that currently humans have an advantage compared to machines are going to be eventually moved over to machines, and that the advantage of eventually the machines will basically have an advantage in many of these tasks. So that's something to think about when you're thinking about what investments to make.
Thank you very much for that tip, Spencer. Moving on to the technological singularity. So first of all, have you heard about Ray Kurzweil and his concept of the technological singularity?
Yes, I have.
And what's your take on it?
Well, I think that as far as we know about the laws of physics, there doesn't seem to be anything preventing, to our knowledge, the construction of a machine that has great intelligence. In particular, we can look and see that it seems to be the case that natural selection over a very long span of time produced human brains, which are intelligent things, and that there doesn't seem to be any fundamental reason why we couldn't reverse engineer the way that those work or implement them in computer code. For example, maybe even at a very unsophisticated level, just trying to simulate every single neuron in the brain on a computer. That doesn't seem impossible. It seems very, very difficult, but not impossible. And if it's not impossible, it means that it would be possible to construct a machine of great intelligence, perhaps greater than human intelligence.
So if you were to rate in terms of probability, how likely do you think it is that we are going to experience some kind of a technological singularity in the near future or in the far off future?
Well, it's a very, very hard thing to estimate. I would be very hesitant to put any kind of probability on that. What I would say is that the human race faces many challenges, things like nuclear weapons, bioterrorism. There are many, many challenges as a race, as a species that we face. If we can survive all of these challenges for long enough, I expect that one day we will be able to figure out enough about how the brain works, or enough about learning theory or intelligence theory in general, that we'll be able to build a really intelligent machine. But I have no idea how to estimate when that could happen, or whether that could happen before we succumb to other challenges.
Well, perhaps we can speculate then a little bit more about, say that this actually does happen. Do you think that the human species is likely to survive such an event?
Well, I think one thing to keep in mind is that when we talk about this question of giving a machine logic versus giving a machine preferences or values, the behavior of that machine is going to depend a great deal on what values or preferences you give it. And if you try to give it very naive ones, it can get you into trouble. If I say to you, would you please get me some spaghetti? You know that there are other things in the world that I value besides spaghetti. You know that I'm not saying that you should be willing to literally shred the world in order to get spaghetti. But if you were to code naively into a extremely intelligent machine, as its only desire, get me spaghetti, it would stop at absolutely nothing to do that. And so the danger is not so much the danger of a machine being evil or a Terminator-like scenario. The danger is that we give it a bad set of preferences or values or desires that lead to unintended consequences. Or I suppose that it's built from the ground up with a set of preferences that are not the preferences reflected by most of humanity. Maybe only the preferences that a certain small group of people cares about.
So in that sense, how concerned are you that sort of the work and the algorithms that you're writing for your smart investment AI can be used eventually by other people for, not such beneficial purposes?
I'm really not concerned about that because what we work in is narrow AI. And the task of taking narrow AI and turn it into general AI is an extraordinarily difficult one. When you design a machine to solve a specific task, it's very, very different than trying to design it to be generally intelligent.
I see. So let me see in that sense, have your ideas about narrow AI or general AI evolved or changed in any way possible since you started your hedge fund and started investing based on the advice from your artificial intelligence?
Well, my views on general artificial intelligence have changed, but not because of my work on the narrow AI so much as just learning about the topic. My thoughts about narrow AI have changed just because when you start actually trying to build machines to do specific tasks, you inevitably learn from your failures and your mistakes and about what works and what doesn't, and why it works and why it doesn't work, and computational difficulties and that sort of thing.
And perhaps now is the time, because we're approaching the end of our interview, to tell us a little bit more about your PhD in mathematics. What is your thesis focusing on, and so on?
So I'm working on two projects right now. One of them relates to measuring the complexity of machine learning. Basically, well, the complexity of machine learning algorithm, I suppose you could say. The idea is it's sort of like Occam's razor. I don't know if you're familiar with Occam's razor, but basically the idea that it's a statement that simpler explanations are better than more complex ones somehow. And it turns out there's sort of something analogous to Occam's razor in machine learning that you can actually prove mathematically, but you have to be very specific and precise about what you mean by simpler explanations and what you mean by better explanations. But then you can show that in a way simpler explanations or simpler models are better, all else being equal. That is, if they have the same predictive accuracy.
We're moving forward here to the last two questions of our interview, Spencer. First of all, can you tell our viewers and listeners where can they go and learn more about your fund in general and your other work also?
Well, there's a little bit about our company you can read on rebellionresearch.com. And in terms of my thoughts personally, I write about them at spencergreenberg.com, which is my website.
Fantastic. And do you have a single message that you would like for our viewers and listeners to take away from this interview today with you? What would that be if you have such a message?
Well, since your listeners are most likely interested in the singularity, I suppose my message would be that to solve really difficult challenges like building a machine greater intelligence than a human, or even just predicting when such a machine might be possible to build or whether we can build it at all, these are really difficult thinking challenges, and they require really precise thinking that's free of logical fallacies, that's free of cognitive biases, because our human brains are capable of an enormous amount, but they also tend to misfire at times and produce fallacious reasoning. They produce biased thinking. And so what I would say, one of the most important messages that I have is to work on your own thinking abilities, to learn how to really hone your thinking. And I have sort of unconventional ways of thinking about this, but learn about the cognitive biases. Go read Wikipedia's list of cognitive biases. Learn about the logical fallacies. Read Wikipedia's list of logical fallacies. And I think that even just that can be very valuable as you start noticing more and more when your brain has these kind of misfires, and you can avoid some of these problems and actually become a better thinker, better capable of tackling really, really difficult questions.
Spencer Greenberg, thank you very much for being here with us today.
Thanks a lot.